Hello students, welcome to Narayan PU College online classes. So in the last video we were discussing about chemical properties of ammonia. So up to 6 properties we have discussed, and the remaining properties we will discuss in this class. And last one we have discussed the last chemical property of the ammonia is reaction with carbon dioxide. So we have completed first one is the basic nature, chemical property 6 we have discussed, and first one is basic nature and reaction with metal salts and formation of complex compounds, oxidation, reaction with halogens. In that one first one is with the chlorine, that is very important for PU examination, and reaction with bromine and also iodine. And last one we have discussed, that is the sixth one, I will write again here, reaction with carbon dioxide, reaction with carbon dioxide. Clear no? You already know that here ammonia whenever react with the carbon dioxide, ammonia reaction with carbon dioxide, and you will get the compound is here. You have to maintain here drastic conditions because both are gases only. Ammonia is gas and carbon dioxide also gas. So that's why reacting two gases. So and it is you have to maintain high temperature and also high pressure, because if you don't maintain high pressure, these molecules molecule of NH3 and CO2 gas molecule will not come close to react each other. So that's why we have to maintain here high temperatures, and that is 453 Kelvin to 457 Kelvin, and also you have to maintain and 220 atmospheric pressure. Clear? Then what you will get the compound is here ammonium carbamate. What you will get the product here, ammonium carbamate. This is intermediate. Clear no? Ammonium, this we will call as a carbamate, NH2COO, it is a carbamate. So that's why what is the name of this compound? It is ammonium carbamate. This is the product. Clear no? And this is decomposed and gives the urea. And this is decomposes means and here NH2CO, NH2 is the urea, and 2 hydrogens and 1 oxygen will be removed as a water. This is H2O and plus, and what is there here, you see how many nitrogen atoms are there? 2. So that's why you have to multiply this one with the 2. Previous I have not balanced this, so 2 NH3 will come here. So then what you will get the compound is NH2 and CO NH2. What we will call this is urea. This compound is what it is here, urea. So whenever ammonia reacted with carbon dioxide, and what is the product you will get here, urea. Clear? And that we have discussed. And next one is, seventh one is reaction with Nessler's reagent. Next one, what not reaction with Nessler, and another one is there, reaction with metals. Reaction with what it is here, metals. Clear? So after then we will go for the Nessler's reagent. Clear? So reaction with metals, you know that ammonia, whenever ammonia react with metals, you will get the metal amides. You will get the what it is here, metal amide. That is clear. So simple example, if I take suppose sodium and treated this one with the ammonia, so one hydrogen will be replaced by sodium and hydrogen gas, and along with metal hydride, which gas will be released here, hydrogen gas. Clear ma? So sodium and NH3, so one of the hydrogen will be replaced by sodium, you will get NaNH2 plus of H2. What you will get here, of H2. One hydrogen means here of H2. Or if you wanted to balance this and multiply total reaction with the 2, then 2 and here 2 and here 2, here 1 by 2 is there, 1 by 2 with the multiply you will get 2, that is hydrogen. Clear ma? So this is reaction. So what we are getting here, sodamide. We have used this one, sodamide. Clear ma? Strong base. Clear? It is sodamide. In the same way, if I take here potassium, then what you will get here, potassium amide. So what you will get here, 2 moles of KNH2. These are very very strong bases, and along with this and hydrogen gas also released. This we will called as a potassium amide. Clear? So this is about reaction with which one here? Reaction with compound that is sodium metal. And next one is 8th one. Clear? I will write here H2O down, here H2O. Clear? So next one is here reaction with Nessler's reagent. A reaction with, very very important for the competitive examination. This is reaction with Nessler's reagent. Reaction with what it is here? Nessler's reagent. Clear? So this Nessler reagent is used to identify the ammonia and ammonium salts. Clear? So whenever ammonia and ammonium salts react with Nessler's reagent, and it gives the brown precipitate. Clear? So if you get brown precipitate, then the molecule may be ammonia or ammonium salts. Clear? So here by using this reagent, ammonia and ammonium salts can be identified by using this reagent, Nessler's reagent. Clear? So what is the reaction here? And you know that whenever ammonia react with Nessler's reagent, what is the Nessler's reagent? K2HgI4. This we will call as a Nessler's reagent. Clear? And this is treated with ammonia NH3 in presence of basic condition. In presence of which condition here? Basic condition. And it gives the compound here is NH2 HgO and HgI plus Ki plus H2O. Clear? And this is we will called as this compound iodide of Malon's base. Iodide of which one here? Malon's base. It is brown precipitate. It forms the what it is here? Brown precipitate. It is brown precipitate. Clear? So what is this one? You see, that's why whenever ammonia or ammonium salts react with Nessler's reagent and gives the which one? Brown precipitate of iodide of Malon's base. Iodide of which one here? Malon's base. Base you don't write here. And Malon's base. This is clear, mates? So now it is a which color precipitate? It will get brown precipitate. Now balance the equation. So here you see how many Hg atoms are there? 2, but in the reactant side only 1 is there. Multiply this one with the 2. When we multiply this one with the 2, how many iodide atoms will be there? You see 2 into 4, 8. But here we have already used 1. So how many left here? 7. 7 means I will multiply this one with the 7. Now potassium atoms balance. And here 7 potassium atoms are there. Clear? But here how many? 2 into 2, 4. And 4 means I have to multiply this one with the 3. Then total 7 atoms balanced. And now you have to balance the hydrogen atoms here. Hydrogen atoms you see, and here 3 hydrogens are there, and here NH2 is there. 1 hydrogen is left here. Total how many hydrogens are there? 4. 4 means I have to multiply this one with the 2. So this is the reaction, very important for the competitive. Directly sometimes they will ask, by using Nessler's reagent, which of the below compounds can be identified? Which one here? Ammonia or ammonium salts. Next one is uses of ammonia. We have discussed about the chemical properties, we have completed, and now next concept is here uses of ammonia. Clear? So it is used in the manufacture of so many ammonium compounds. Clear? Like NH2CO NH2. What is this compound here? Urea. Clear? And also ammonium salts, like ammonium nitrate. What we will call this is ammonium. Clear? Nitrate, ammonium nitrate. Clear? And also ammonium sulfate, ammonium phosphate, ammonium. This is ammonium phosphate. Clear? So ammonium phosphate. So like so many ammonium, salts or compounds can be prepared by using what it is here, ammonia. And the next one is here, important point, it is also used in the preparation of HNO3, nitric acid. What it is the name of HNO3? Nitric acid, by using Ostwald's process. Very important this is, and we will discuss in the next video. We may discuss about the preparation of HNO3 by using Ostwald process. Another very important question for the 3 marks. Clear? I already said Haber process, Ostwald process. Another one is their contact process. Clear? So definitely among these 3 you will get one question for the 3 marks. Clear? So that's why that also we will prepare. How we will prepare means we will use by using ammonia only. And next one, it is also used as a refrigerant in and ice factories and cold storages, and it is used as a refrigerant and also used as a laboratory agent. You have already done practicals in the laboratory, so we have used so many times this what it is here, ammonia. Clear ma? As a lab, ammonia we will not use here ammonium solution like ammonium hydroxide. Clear? So these are about uses of ammonia. We have completed first one is the preparations of ammonia, structure of ammonia, physical properties, chemical properties and uses. Clear ma? And next we will go for the oxides of nitrogen. Clear ma? So next one is oxides of nitrogen. Clear ma? So we have already discussed nitrogen can form many number of oxides because it has a capability to form the p pi multiple bonds with the highly electronegative atoms like oxygen. Clear ma? So that's why, and nitrogen will form almost 5 types of oxides. One is we can say 6 type. One is dimer of NO2, that is also will be included here. So what are those? And we will discuss one by one, and you have to draw the table like this, because very important this table for the competitive examination. So many questions, 1 or 2 questions may come. Clear? So first one, name of nitrogen oxide, and formula, oxidation state, preparation method, properties, and next one is structure. Clear ma here? See the first one. First one is compound dinitrogen monoxide, N2O. Dinitrogen monoxide. Oxygen is 1. Clear ma? What is the oxidation state? If you know how to calculate the oxidation state, oxygen is -2 and nitrogen X. So 2x minus 2 is equal to 0. So X is equal to what it is ma? 1. Clear? So that's why I will not discuss here how to calculate the oxidation number. You already know. Clear? So that's why, what is the oxidation number here? 1. So we can write nitrogen 1. 1 means it indicates oxidation number. Nitrogen 1 oxide. Nitrogen 1 oxide means it is N2O. Clear ma? So that is, and can also be called as laughing gas. Clear ma? So it is N2O is called as which one? Laughing gas. If you inhale the N2O gas without reason, you will get laugh. Clear? So that is what you might have seen the movie Sai. Isn't it? In that one they will throw one balloon which contains the N2O gas, and they laugh each other without any reason. Clear? So that is laughing gas. And here how to prepare this? Very important. Ammonium nitrate, and previous we have discussed ammonium nitrite. Ammonium nitrite means what formula? NH4NO2. Ammonium nitrite, if you heat, then what you will get? And 2 oxygens and hydrogens are there. You will get, it will be removed as a 2 water molecule plus, and here which one is the nitrogen? N2 is there. This is preparation of N2. Previous we have discussed. If you take ammonium nitrite, nitrogen is a product, but here what we have discussed, and we have taken ammonium nitrate. Ammonium nitrate means, and 4 hydrogens means what it means? 2 water molecule will be removed. 2 water molecule means how many oxygens are removed here? 2. So 1 will be left here. So N2. So very important, it is a colorless neutral gas. It is what is colorless neutral gas. And what is the structure here? Clear? The structure of the compound is, this is N triple bond NO. Clear? You already know that. Nitrogen, what is the electronic configuration? 2s2 2p3. Clear ma? So 2s2 2p3, it has 3 unpaired electrons, so that's why it will form 3 bonds. Clear ma? And it will, nitrogen will form 4th bond when it donates its pair of electrons to others. Clear ma? So when it donates pair of electrons to others, then you know that bond will be a coordinate bond, or we can call it as a dative bond. You know covalent bond, how it will form? One atom will give one electron, another atom will give another electron. By sharing these two, you will get one bond that we will call as a covalent bond. Ionic bond means what? Electrons will be transferred. By transferring the electrons, we will get the ionic bond. Coordinate bond or covalent bond, you know, coordinate bond or dative bond, how it will form? And here one atom donates 2 electrons, and another atom should have the empty orbitals, or you can say capability to accept those electrons. Clear ma? So that's why if nitrogen using its pair of electrons in the bond formation, then if using pair of electrons means it will form the, you know, which bond? Dative bond, that you have to remember. Clear here? It is losing electron, pair of electron. If it lose, then it gets the which charge? Positive charge. That is, you see here, this nitrogen if I see, and it is making 3 bonds with the nitrogen, so means these 3 electrons have been used. Clear ma? So, and another oxygen is there. To make a bond with the oxygen, it donates which one? It lone pair of electron. Lone pair of electron means which bond you will get? A dative bond. Clear ma? That I have written like. So otherwise you can write here also. So N and triple bond N, it is making bond here. When it makes 4th bond, when it donates lone pair of electron, donates lone pair of electron means losing electron, positive charge, it gaining electron, negative charge. That is. Clear ma? So this is about the, what it is ma here? N2O. Clear? Very important, it is a neutral gas. Clear? So next one is nitrogen monoxide. Nitrogen monoxide, and this can also be written as a, what is the oxidation state here? This is -2 means it is a +2 oxidation state. So nitrogen 2 oxide can also be called here nitric oxide. What it is here? Nitric oxide. Clear? So you will get, what is the oxidation state here? 2 +2. How to prepare this one? So we have the preparation method here. Take the sodium nitrite and treat it with, so you know, iron ferrous sulfate in presence of acidic medium. You will get the Fe2SO4 ferric sulfate and sodium bisulfate and NO and H2O. Clear ma? So this is preparation of which one here? NO. So important here is properties. Clear? So preparation, because we will discuss NO preparation, so don't bother about this, and you have to be careful about the properties. Clear? So first one, same like N2O, it is also colorless neutral gas. Among the nitrogen oxides, nitrous oxide, this can also be called as a nitrous oxide and a nitric oxide, both are which one here? Neutral gases. Clear? So this can also be called as a nitrous oxide. Clear? So it is a colorless and neutral gas, odd electron molecule. NO is a, nitric oxide is a odd electron molecule. See here the structure. Clear ma? So nitrogen, I already previous mentioned here, how many electrons are there? 2s2 2p3, and here 1 electron, 3 electrons are there. Means nitrogen making two bonds here, one sigma bond and one pi bond, means how many electrons are used here? 2 electrons. 2 electrons are used means one unpaired electron is left and one lone pair is left here. That is clear ma? So that's why it is having, what it is ma? One unpaired electron, so that's why it is a which molecule? Odd electron molecule. If it is a electron, single electron is there, and that molecule we will consider it as a paramagnetic. Clear ma? So paramagnetic, but in which state? And it is a paramagnetic. NO is a paramagnetic in gaseous state only. Clear ma? You know that gaseous state means when it is in the form of gas, and you know NO molecules are very far away from each other. Clear? But and diamagnetic in solid and liquid state. Solid and liquid state. Why? Because means because of dimerization. Because of which one here? Dimerization. Why? Because you know liquid and solid means these molecules come close to each other. When they come close to each other, you already know NO means it is having, you know, NO means it is having one unpaired electron. Another NO molecule is having what it is, unpaired electron. When they are coming close and these two electrons are shared, and you will get the bond between these molecules. And it is previous, it is a what it is, monomer. Now what it is, dimer. What it is here, dimer. Two molecules are joined by a bond, so that's why what it is here, they are you see now, previous it is in a gaseous state, it has one unpaired electron, but in solid and liquid state, have they any unpaired electrons here? No. So that's why it is diamagnetic. Diamagnetic in solid state and liquid state, because of which one here, dimerization. Clear? And next one, this is only the oxide which can act as a both oxidizing and reducing agent. Remaining all nitrogen oxides are only act as a oxidizing agents. Clear? So this is about the what it is here, nitrous oxide. You can write here nitrous oxide also, nitrous oxide. Clear? It is a nitric oxide. So we will go for the next one. Next oxide is, we have discussed about the nitrous oxide and nitric oxide, N2O and NO. And third oxide is here N2O3. What it is here? N2O3. Dinitrogen trioxide. That is the name. Dinitrogen trioxide. R can also be called. What is the oxidation number here? Oxidation number is +3. Nitrogen oxidation number how much? +3. Clear? So +3 means nitrogen 3 oxide, and can also be called as nitrogen sesquioxide. Clear? These are the three names of N2O3. Clear? And here +3 oxidation state. How to prepare this molecule? Preparation is very easy. So take the nitric oxide and nitrogen dioxide. This is N2O. Clear? So N2 plus O3, and this preparation should be done below the 250 Kelvin, because above the 250 Kelvin this molecule become unstable. Clear? So you can maintain the temperature up to the 250 Kelvin. So that's why then NO2 react and it gives the N2O3. Clear? So it is a blue color solid. N2O3 is a blue color solid, and I said except the N2O and NO, remaining all oxides are acidic oxides only. Clear? And the third one, just now I mentioned, it is stable up to the 250 Kelvin temperature. If you maintain above the 250 Kelvin, then this molecule undergo dissociation and gives NO plus NO2. Clear? And the next one is important point I have written, very very important. This is for the competitive examination. N2O3 is a N-hydride of HNO2. N-hydride of which one here? HNO2. Clear? What is meant by anhydride? Anhydride means removal of water. Anhydride means what? There should not be water. You have to remove the water. Remove the water means it is a N2O3 is a anhydride of HNO2, means remove the water from the HNO2, then you should get the N2O3. That is the anhydride. So that's why remove the water. To remove the water, how many hydrogen molecules should be required here? 2, but here 1. Multiply with the 2. Multiply with the which one? 2. Then remove the water and H2O. Then what is left here? You see N2 left here. N2. 4 oxygens are there. 1 oxygen here. So N2O3. So that's why N2O3 is a N-hydride of nitrous acid. What is the acid here? He is nitrous acid. Clear? It is not a preparation. Just this is point. I explained anhydride of HNO2 means this is clear. So that's why if you remove water molecule from HNO2 you will get N2O3. If you add this water to N2O3, you should get which one? Nitrous acid HNO2. That is only I have mentioned. N2O3 when reacted with the water, you will get the what it is HNO3. So HNO3 means which one? It is acidic. So that's why N2O3 is a acidic oxide. Clear? You already know that non-metal oxides are mainly, it shows the acidic character. Clear? So this is about, and you see the now structure. Structure means we have 2 nitrogens and 3 oxygens should be arranged. Clear? You know that nitrogen will make a double bond with the oxygen. So 2 nitrogens I connected with the single bond. I added here 1 nitrogen, here 1 oxygen. Clear? To 1 nitrogen what I will do, I will add 1 oxygen, and another nitrogen I will add another oxygen. Nitrogen forming how many bonds? 3 bonds. 2 and here 1. This nitrogen also 2 bonds here, 3, total 3 bonds over. What about another oxygen? So that's why it use its pair of electrons, lone pair of electron is there, it use its pair of electrons to make a bond with the oxygen. So what bond it is? Dative bond. Clear ma? So or otherwise you can write N double bond O and here N double bond O. Nitrogen is forming fourth bond, means nitrogen should get which one ma? Positive charge. Now it is gaining electrons, so negative charge. Clear ma? So this is about the nitrous, dinitrogen, trioxide. And next one, fourth one is NO2, nitrogen dioxide. Clear ma? Nitrogen dioxide. Or what is the oxidation number here? It is minus 2. 2 into 2 minus 4. Minus 4 means it should be a plus 4. That is oxidation state. Clear ma? Can also be called as a nitrogen 4 oxide. Clear? The preparation here is, take the lead nitrate and heat it. You have studied this one in the first year already. So lead nitrate, and if you heat, then you will get the lead oxide, nitrogen dioxide. What it is here? Nitrogen dioxide plus oxygen. Balance here. So if you take here 2 moles, then you will get the 2 PbO. So how many nitrogens are there here? 4. 4 means you take here 4 nitrogen. So oxygens here 2 into 3 6, 6 into 2 12, and here 4 into 2 8, 8 plus 4 12, balanced. Clear? So next one, important is properties. Clear? Same here, it is a gas. NO2 is a which one here? Gas. Clear? NO2 is a gas. Which color it is? Brown color. Colors also very important. Clear? Brown color gas. And you know, this is NO2, all except what I again I am saying, except N2O and NO, remaining all oxides are acidic in nature. So it is a acidic oxide, and it is a odd electron molecule. We have 2 odd electron molecules in the nitrogen oxide. One is NO and another one is the NO2. Clear ma? Odd electron molecule. How you can get means, see the structure here, then we will discuss. By seeing this structure we can say it is odd electron molecule. And now it is a odd electron molecule in which state? Gaseous state. Clear? But in the solid state, you know, if you decrease the temperature, then NO2 and NO2 molecule come together. This is NO2 molecule having one unpaired electron, and this is also NO2 molecule having one unpaired electron. If you are cooling the temperature, molecule will come close to each other, then and one electron and one electron sharing and make one bond. That is dimerization. N2O4, that is on cooling down, and you know it will be dimerizes. Clear ma? So N2O4 you will get it. Clear? And you see, it is a, I said, odd electron molecule. How it is odd electron molecules means, you see here. Clear ma? And nitrogen is there. Nitrogen, I already said how many electrons are there, and 3 unpaired electron and 1 lone pair electron, and 2 hydrogens are there, 2 oxygens are there. 1 oxygen will be attached to the nitrogen by a double bond. If another I will write, that should also be attached to the double bond. But here nitrogen having how many unpaired electrons here? 3 only. It can make 3 bonds, 1, 2, and here 3. Fourth bond, when it will form, form the fourth bond, it donates its pair of electron. Clear? So that's why here what it will do, and these 2 electrons are used to make a 2 single bonds with the oxygen. So this pair of electron, it gives lone pair of electrons, it donates to the oxygen and form a dative bond. So that's why here one unpaired electron is left here. That is so, that's why it is a odd electron molecule. If it is an odd electron molecule, another point we can write, it is a paramagnetic. What it is ma here? Paramagnetic. In which state ma? In gaseous state. In gaseous state, because in solid and liquid state it is a it dimerizes, so that's why it is a diamagnetic. Clear ma? So this is about the, what it is ma here? Nitrogen dioxide. So next oxide, nitrogen oxide is N2O4, that we will call as a dinitrogen tetroxide. Clear ma? Or what is the oxidation state of the nitrogen here? +4. So that's why we can call the nitrogen 4 oxide. Clear ma it is? So what is the oxidation state here? +4. And how to prepare? Simple it is. You know that by NO2, I already mentioned, if you are cool down the temperature of the NO2, it easily dimerizes and gives the N2O4. That is only the preparation here. 2 molecules of NO2, because odd molecule it will have 1 unpaired electron. If 2 molecules means they combined and gives the N2O4. On which one? Cooling. If you cool the NO2 molecules here, you will get N2O4. If you heat N2O4, then it will give again what it is, NO2 molecule. Clear ma? So this is preparation, and also it is a colorless solid, and I said acidic, it is all oxides are acidic except N2O and NO. And very important here is N2O4 is a mixed anhydride of HNO2 and HNO3. Very important, this is for the competitive. Clear? So which of the following oxide is a mixed anhydride of HNO2 and HNO3, they will ask. Clear ma? So what is that one here? N2O4. How means, you know that if I take, this is the preparation. Clear ma? So just I will mention, I will write here. So HNO2 means just now only we have discussed. And remove the anhydride means what we have to do? Remove the water molecule. To remove 2 hydrogens required, so multiply with the 2. Then what you will get, ma? N2O3 plus what you will get? H2O. And take this one also. What it is here? HNO3. This is HNO3. Clear ma? And this is also multiply with the 2. Then what you will get, ma? N2O5 plus what it is, ma? H2O. Clear? And combined this, you will get N4O8 can also be written as 2 moles of N2O4. That is clear. So that's why it is a N2O4 is it is a anhydride of which one? HNO2 and HNO3. That is clear, it is. So that's why N2O4 is a anhydride of HNO2 and HNO3. Means if you are removing the water molecule from this, you will get N2O4. If you add water molecule to N2O4, again you should get what it is, HNO2 and HNO3. That is only the properties here. Clear, it is. So it is not a preparation, just this is explanation of anhydride. Clear ma? So this is, if you add N2O4, if you add the water to N2O4, then what you will get the products here? Nitrous acid and nitric oxide, nitric acid. Clear, it is. So this is, next one is structure. Structure means what it is here? 4 oxygens are there and 4 oxygens, 2 nitrogens. So that's why 2 oxygens you have to attach to the nitrogen. One is with the double bond and another one should be with the dative bond. That is R, you can write in this way: nitrogen and nitrogen double bond O, and here a positive charge on oxygen, nitrogen, and here also there is a positive negative charge on oxygen and positive charge on nitrogen, because nitrogen is donating its pair of electrons, positive, gaining electron oxygen, negative. Clear ma? So that is about the what it is ma N2O4. And last one here is N2O5. What it is ma here? N2O5, dinitrogen pentoxide. That is dinitrogen pentoxide, and can also be called as, what is the oxidation state? I will calculate here, you know already, 2x and here -2. So that's why 5 into -2, 10 is equal to 0. So 2x is equal to 10 and x is equal to what it is ma 5. That you already know how to calculate. That is 5. Clear ma? And you know how to prepare this one. And we will take the HNO3 and here P4O10. P4O10 means what is ma? Phosphorus pentoxide. P2O5, you know, phosphorus, arsenic and antimony oxides. Trioxides and pentoxides are dimers. So that's why P4O10. It is one of the dehydrating agent. It removes the water molecule from HNO3 and gives the N2O5. Clear ma? So by removing water molecule, and it gained the water molecule from HNO3 and converted into metaphosphoric acid. This is what we will call here metaphosphoric acid. Metaphosphoric acid. Clear ma? So 4 phosphorus are there, multiply with the 4. So that's why you will get here 12 oxygens and here 5 oxygens. So if you balance, you will get the 4 NO3 and 2 N2 here, because 4 nitrogens here and here 4 nitrogens, and it will be balanced. Balancing is not that much important here. What the products you are getting, that is important. Clear ma here? So how to balance also next we will discuss easily how to balance the equations. You have already studied in the first year redox reaction, ion electron method. By using ion electron method, we can easily we can balance these equations. Clear ma? So I will discuss that one. Next HNO3 is there, how to balance the equations, I will discuss that. Clear? So next one, properties. If you see, same like it is also colorless solid and acidic oxide. Clear ma? And N2O5, it is stable at room temperature. Above room temperature it gives the NO2 and O2. Clear ma? And very important, in the solid state it is existed as a NO2 plus and NO3 minus. You see N2O5, but in the solid state it existed as a ionic compound. Existed as a which compound ma? Ionic compound. So that's why it is called, also called as a, this we will call as NO2 plus, we will call as a nitronium. This is nitronium. This we will call as a nitrate. So that's why N2O5 can also be called as a nitronium nitrate. Nitronium nitrate. It exists as a, in the solids as ionic compound like ions NO2 plus and NO3 minus. Clear ma? So structure, if you see the structure here, so 5 oxygens are there, 2 nitrogens are there, 4 are there, we have arranged in this way. So that's why 5 are there, we will get here N bond here. Linkage of 2 nitrogens should be linked with the oxygen. Same, one oxygen will be, connected with the double bond, and another oxygen will be connected to the dative bond. Clear ma? So this is about the, what it is ma here, oxides of nitrogen. And very important in this case, color, and which one is paramagnetic, and what is the anhydride. If you take the NO and N2O, both are neutral gases. Remaining all oxides are which one? Acidic. Clear? And another important point is here, first 2 and last 2 means N2O and NO, N2O4 and N2O5, all are which one ma? Colorless only. First 2 are gases and the last 2 are solids. Middle 2 are there, that is N2O3 and NO2. N2O3 is a blue color solid and NO2 is a brown colored gas. Colors also important. Clear ma? Another one is anhydride. Anhydride we have 3. One is N2O3. It is a anhydride of HNO2. N2O4 is a mixed anhydride of HNO2 and HNO3. And last one is there here is, what it is ma here? N2O5. It is a anhydride of HNO3. Take here, I have already mentioned, suppose HNO3 if you take, remove the water molecule, what you are getting here? N2O5. That is, N2O5 is a anhydride of HNO3. Clear ma? So this is about the oxides of which one ma here? Nitrogen. Clear ma? Clear ma? So we have discussed about the oxides of nitrogen, and the next one is oxyacids of nitrogen. Clear ma? Oxyacids of nitrogen. Oxyacids means to the central atom. Clear ma? So OH and one double bond O should be added. It is not mandatory condition that always and double bond O should be added here, but to the central atom there should be any central atom. If I take here central atom, clear ma? So oxyacid means to the central atom there should be a one OH. In some other conditions, and here what it is ma? Double bond O also be present, and those type of acids you see like a C double bond O OH, what we will call ma? Acid. Clear? Or if you take only OH is there, alcohol, acids, like that only. One sometimes double bond O attached to the central atom and also OH, both should be added, or sometimes only central atom to the only central atom OH is added. Only OH is added to the central atom sometimes, and those type of compounds we will called as a oxyacids. Clear my it is? So we will discuss, and nitrogen forms 5 types of oxyacids. Clear? So nitrogen forms how many types of oxyacids ma here? 5 types of oxyacids. Among that only one is the stable, and that is nitric acid, and that we will discuss in this chapter. So what are those 5 oxyacids that nitrogen forms are? The first one is, clear ma? Hyponitrous acid. What is the first one ma here? Hyponitrous acid. Clear? And second one, hydronitrous acid. Hydronitrous acid. Clear? And third one, nitrous acid. Nitrous acid, just now only we have discussed HNO2. Clear? I will write the formulas also. And the fourth one is nitric acid. Fourth one is what it is ma here? Nitric acid. And fifth one is permanganatic nitrous acid, nitrous acids, and these are the 5 oxyacids of the nitrogen. I said among all, which one is the stable here? Nitric oxide. Clear? So this is what it is my name. Like just if you draw like a table, name, and if I write here formula, what is the formula of this compound? Hyponitrous acid. What is the formula? Means H2N2O2. Clear? No? So what is the hydronitrous acid? H4N2O4. This is hydronitrous acid. Nitrous acid, you already know, HNO2. This is what it is, nitrous acid. And next one is nitric acid. What is the nitric acid formula? HNO3. Clear? And pernitrous acid. Pernitrous acid also formula is HNO3, but structure is different. Clear? So formula I will write here, structure of the molecule. Clear? So nitrous acid means here hyponitrous acid. So what will be there here? OH and OH. I said, and to the central atom OH should be present, and those type of acids we will call as a oxyacid. Sometimes to the central atoms central atom double bond O also attached in the oxyacids. It can be nitrogen is present as a central atom, then we will call as a oxyacids of nitrogen. Phosphorus is there, oxyacids of phosphorus. Clear? Ma? Sulfur is there, oxyacids of sulfur. Next one is structure of this compound is N and OH and OH, OH, OH. This is the structure of this compound. Clear? Ma? HNO2. HNO2, what is the structure? H and double bond O. You see here, to the central atom OH is present, and also which one? Double bond O. Clear? And next one, nitric acid. What is the nitric acid formula? OH, N double bond O, and what is the one coordinate bond here? Clear? This is structure. And pernitrous acid, and H O, and here what it is here? N double bond O. This is pernitrous. Nitrous acid means what it is? OHNO, OHNO. Per means oxygen will come, peroxy bond. Clear? So these are about what it is here, name, formula, structure, and basicity. Basicity also we will write here. Basicity. Basicity means what is how many OH groups? Means hydrogen should be attached to the highly electronegative atom like oxygen, and that is how many replaceable hydrogens are present in the molecule. That we will call as a basicity. Replace, when it will be replaced, hydrogen, if hydrogen is attached to highly electronegative atom, that is. So here H is attached to the highly electronegative atom, that is what it is oxygen. How many are there? 2. So that's why basicity is 2. And here 4. And here only 1. And here only 1. And here only 1. And this is about the what it is here, oxyacids of what it is? Nitrogen. 5 hyponitrous, hydronitrous, and nitroxylic acid can also be called. This is nitrous acid, nitric acid, and pernitrous acid. As I mentioned, among all these, this is only the stable, remaining all are unstable. So that's why in this class we will discuss about the nitric acid. Clear, ma? Clear, ma? So next one is oxyacids of nitrogen. Oxyacid of nitrogen, that is stable oxyacid of nitrogen, that is what it is here, nitric acid. So what is the formula of nitric acid? HNO3. It is a monobasic because only one OH will be attached to the nitrogen. Clear, ma? So we will discuss first of all we will discuss the preparation methods, then structure, and after then physical properties, chemical properties, uses. That is common. Clear, matters? So first one is preparation method, and first preparation method is here laboratory preparation method. Laboratory method. How we will prepare nitric acid in the laboratory. Clear, ma? So simple. This is, and take the sodium salts of nitrates or salts of nitrate. Take the sodium nitrate or potassium nitrate and treated this one with the acids. Clear, ma? H2SO4, sulfuric acid. Then what you will get, you see, SO4 is there. So what you will get here, one of the hydrogen, H will come here, then what you will get, HNO3 plus, what it is, NaHSO4, this is. Clear ma? This is laboratory method. What we will call this is nitric acid. Clear ma? Nitric acid. Clear? So this is the which one laboratory method. Take the sodium nitrate or potassium nitrate treated with the sulfuric acid. You will get the what it is ma? HNO3 nitric acid plus sodium bisulfate or sodium hydrogen sulfate. Clear ma? So this is about the laboratory method. It is small scale we will prepare, and in the large scale, if you want to prepare large scale and you have to follow the one method that we will called as a Oswald process. Very important. This is for your PU examination, 3 marks. Clear ma? So you have to put here star marks. Clear ma? So I already mentioned Haber process, and second one is Oswald process. Clear? By using Oswald process, we will prepare the nitric acid. Clear ma? So how to prepare? Clear? And this preparation of nitric acid by Oswald process involves 3 steps. How many steps involves here? 3 steps. Clear? What is the first step? One by one we will write here. Step 1. Clear? Step 1. What is the step 1 is? Clear? Catalytic oxidation of ammonia by atmospheric air. Clear ma? So what it is here? Catalytic oxidation of ammonia by what it is ma here? Atmospheric air. Clear here? Now what is the ammonia formula? You already know, NH3 plus catalytic ox means atmospheric air, means what you have to take ma? Oxygen. Very important here, catalyst. Clear ma? So platinum and rhodium gas catalyst. This is the catalyst. What is the catalyst ma here? Platinum and rhodium, and you have to maintain here 500 Kelvin temperature and also 9 bar pressure. Clear ma? So these conditions are very important. If you don't write these conditions, you will lose the mark. Clear ma here? So now how to write this is, you see now. So you will get what the compound you will get? You will get the NO plus what it is ma here? H2O. This is the compound. Clear? Balance here. If I balance here, see how many hydrogens are there? 3 hydrogens, and this side how many hydrogens are there? 2 hydrogens. So I will multiply this one with the 2 and I will multiply this one with the 3. Clear ma? Then hydrogens are balanced 3 into 2 6, and here 3 into 2 6. Clear ma? Next you have 2 nitrogens. How many are there here? 2. So that's why I have to balance this one with I have to multiply this one with the 2. Clear ma? Then oxygens, you see, oxygens 2 and plus 3, total how many? 5. 5 means what I have to do? I have to multiply this one with the 5 by 2, because 5 by 2, and how many oxygens are there here? 2 oxygens, 2 get cancelled, then 5 oxygens you will get. Clear ma? So but you know that it is a fractional 5 by 2, so that's why I will multiply whole the equation with the 2, then 2 into 2 what you will get ma? 4, and if I multiply with the 2, 5 by 2 into 2 you will get only 5, means you have to multiply this one with the which one ma? 5, and here 2 into 2 4, and here 6. Clear my test? So this is about the what it is here, balancing, how to balance the equation. Clear? Or you can use the oxidation number method also can be used to balance this equation. Clear? Because you have to balance, otherwise you will not get the marks. Clear? This is the first step. Clear ma? Next, step 2. What is the step 2 here? Clear? Step 2. So in this one, the nitrogen, here what is the name here? Nitric oxide. What it is formed here? Nitric oxide. The nitric oxide combines with the oxygen to give the nitrogen dioxide. In the first step, nitric oxide will be formed. In the second step, you will get the compound is nitrogen dioxide. So what is the here? Nitric oxide. Right here. Nitric oxide means what it is nitric oxide, NO, thus formed in the first step, combines with oxygen to give what it is here? nitrogen dioxide, NO2, to give what it is here, NO2. So I will write here, so what it is here, NO plus oxygen, you will get the compound what it is here, NO2. Clear? So here 2 oxygens, here 3 oxygens are there. So what I will do, I will make this side, even number by multiplying with the smallest even number, that is 2. So 2 oxygens here, 2 oxygen, 4. So I will multiply this one with the 2. So this is the nitrogen dioxide. What we will call here, nitrogen dioxide. This is the which step here? Second step. Clear? Last one. So here third step. Clear? So third step, step 3. So what is the step 3? Clear? So step 3, nitrogen dioxide, NO2, and NO2 reacts with water. Reacts with what it is, water, to form HNO3 and nitric oxide. Clear? This is the third step. Clear? And what is the nitrogen dioxide, NO2? This is NO2 reacts with which one? Water. Water means what it is, H2O. Then what the compound you will get here? Final compound, that is a HNO3. Along with this you will get the NO. Along with this what you will get here? NO. Clear? So balance this equation. Here how many hydrogens are there? 2. But here how many are there? 1. So multiply this one with the 2. If I multiply this one with the 2, and here are nitrogens, you see how many nitrogens are there? 2 plus 1, 3. So that's why I have to multiply this one with the 3. Clear? So oxygens how many are there? 3 into 2 6 plus 1 7. 3 into 2 6 plus 1 7. It is balanced. Clear? So finally what we are preparing? We are preparing nitric acid. Clear? So this we will called as a preparation of HNO3 by using Ostwald process. And the NO which is formed here again recycled in this reaction. The NO which is formed here, NO is recycled in this reaction. What recycle? NO is formed here. Again you need not to take the NH3 and oxygen here. Same NO again react with the oxygen will give the NO2. This NO2 again react with water gives the nitric oxide. This is again will form which one? NO. It is recycled in the reaction. It is involving and again finally it is forming. Clear? So here you will get by doing the distillation, you will get the HNO3 is here 68% by mass of what you will get here, HNO3 in this reaction. By distillation we will concentrate the HNO3 by the distillation up to 68% by mass. Clear? So this is about preparation of what it is here, HNO3 by Ostwald process. Very important. This process is for your PU examination for 3 marks.